Hi everyone. So I'm actually a researcher, which I have both the background from the electrical engineering and also mechanical engineering. So after I actually dive into some of the tutorials, and if you search it from Google, FPAA tutorial, so it's actually kind of very difficult to find a very systematic tutorial to teach you how you can actually start from a beginner and gradually learn everything and then eventually can make some, I would say, a bit more complicated circuit design in FPAA. So here, based on this, I would say gap. So I'm planning to make a FPA tutorial for all of us. So as most of you then don't have to go through the same difficulties and hard times that I have gone through before. And here, yeah, the as you can see, the bottom one, the bottom left, this is actually one of the FPA circuit that I made. So this one has already turned into a journal article. So this is actually my supervisor, PhD supervisor, his lab. So though I have graduated from his lab, but I'm still actively working with him for some interesting research projects. And also we keep also publishing some patents. And here, this is our topic for today. So as you can see, here are some of the table of contents. So basically, they are divided into three different sections. How FPA work, and why do we use FPAA? Are there any advantages of using FPAA, and what are other disadvantages might have? And how can we quickly set up FPAA so that you can start to simulate some, I would say, simple circuit model in FPA simulator. So here, it's just a very simplified model. So just a quick, I would say, introduction of FPA itself. So instead of FPA, there are quite a few of, as you can see, I call it CAP. So CAP itself stands for configurable analog blocks. So instead of each one of the CAP, you actually have a lot of CAM. CAM. It stands for configurable analog modules. So each one of the analog module, I would say you can use each one of the CAM to have, let's say, some electrical components. You can have, let's say, op-amp integrator, and you can have something like a inverting or non-inverting amplifier. You can also do something like math operations such as subtraction or addition between two different components. And between, I would say, different cap, so you can connect one from another. Let's say I have one output from cap one, and I would like to communicate with another different caps. So you basically need to communicate between them with connecting wires. So similarly, so you actually have four different caps, and each one of them have their own capacity. And if you use up all of the capacity from all of the caps, then you were not able to add more, I would say, modules to do more mass operation. And itself, I would say FPA is based on switched capacitor technology. So this is just a very simplified model. So basically, S1, S2, S3, each one of them just stand for a general traditional switch. So if you switch different, if you close different switches at different times, so different capacitors will be in effect. And so basically, that's why they call it switch capacitor. And different capacitors, when they are in effect in different, I would say, phase in a single clock frequency, so then you will be able to probably generate different functionalities. So you can use the combination of them to mimic some of the electrical components, such as resistors, right? So other than that, I would say they are actually internally reprogrammable, and that's why people are so happy about this functionality. So you can actually design some sort of the circuit just by simply change some of the setup in FPA simulator. I'm going to discuss more details in later slides. So here, you might be very interested in or were thinking, why do we need to use FPAA? Is FPAA itself really intriguing, or are people thinking like it can actually outperform the other, I would say, such as some others designs, such as PZB design? Um, so we were looking at some of the traditional designs. So this is a map that I actually, from what I understand. So when I was working on how can I map the mathematical nonlinear differential equation to some experimental setup, such as analog system. So what I did is that I initially simulate everything from a SPICE-based simulator. And when that simulator worked, that even the simulator make it work itself took me a few, I would say, weeks. And then I started to build them in breadboard circuit. And breadboard circuit, whenever that is working, so you will have a lot of troubleshooting, but that might take you another few weeks. And when that works, you might think, okay, then before I finalize my experimental setup, I might need to have a more robust, stable, and maybe more, I would say, less sensitive to noise design, such as PCB design. And you will start to spend another maybe a few weeks to make your PCB design work. And eventually you get your final results. And the entire process, I would say, can maybe even take a few months, or can be half a year. While when people, I would say, have another new design field, programmable analog array, this is the full name of FPAA. So when people are thinking about a new design, so that we can actually use a simulator, and so FPAA itself actually is the one that I use is actually from Anadigm company. They actually have a simulator here, as you can see here. So this simulator, you can put a lot of different modules. Each one of the module can act as, let's say, integrator or inverting or non-inverting amplifier. So you might spend maybe a few weeks to learn how those modules work, and you can read their documentation and dig through how those documentation work, or each one of the module, what is their functionalities. So you might spend a few weeks, but after that, whenever you are familiar with FPAA simulator design, so you can simply put all of the, I would say, modules in the simulator and connect each one of them. Then you eventually get I would say, a very complicated circuit design. So after that, after your simulator model is ready, then just simply download to your FPAA board. And then after that, you can just check out how your results look like. And that, I would say, maybe initially you might spend a few weeks or even a few months to learn how the simulator or FPAA itself works. But whenever you are familiar with it, I would say, maybe just a few days for a very complicated circuit, then you are done. So it might, in the long run, save you, I would say, quite a long time. So after that, so I'm going to show you like how can we quickly set up FPAA. So here, this is how the original FPAA board looks like. So this is the side view. So here, there is a, I would say, USB port where you connect one terminal to FPAA and another terminal to your desktop or laptop. And after that, so FPAA itself is actually running in a power supply ranging from 4 to 6 volts. So generally, when I use it, I generally give it 5 volts. So, but if you have more complicated circuit design and you need more, I would say, configurable analog modules, then it consumes more power. So here you have two ways. One, you can use an adapter. So that adapter can give you a very stable power input. Or you can use an external power supply, and you can connect it from here. You see that here is ground and also plus. You can use some jumper wires, just connect to an external power supply. So after that, so I would say you also need to download the FPAA Anadigm simulator. So you can just do it from this website. Whenever you download that simulator, you have to check out one more thing from step 2. So from step 2, you go to your device manager. So after you connect the cable, USB cable from the FPAA to your laptop, so from device manager, so you have to check out your USB port, which USB port is actually communicating with FPAA. It's generally shown from here. So my one, since I'm not connecting any FPAA when I was making this tutorial, so but when you connect it, and make sure you also power your FPAA. So when you power your FPAA, let's say at 4 volts, and when there isn't any other, I would say, circuit that were already downloaded to your FPAA board. So when you read your current readout from your power supply, it's generally show you 100 milliamps. So after you check out which I'll say port is actually communicating with your FPAA, so you go to your FPAA simulator. So that Anadigm Designer 2, you open it up, and here at the very top, there are some user interface setup. So just simply go to settings here. There is settings, and click on settings, and from there is another selection. You can just simply go to preference, and after you go to preference, so here check out from the port. So the port actually tells you which port you want your FPA simulator communicating with. So check your port from your step 2. So generally from my one is port 3. So you just click select port and use the correct port, then you will be able to build up the correct connection from FPAA to your laptop. Yeah, that's simply what I have for today. Just a very quick introduction for FPAA and how can you quickly communicate FPAA with your laptop or desktop. So later on, I will gradually show more examples, and at last, I might show more complicated project where I might just show you how you can actually use FPAA to build up a something like a nonlinear differential equation, or is very simple nonlinear differential equation or second order system. And I hope that people like me, like when I was working on FPA, I actually didn't find out that much tutorial, and I keep struggling for quite a long time. So, but after I struggled, then I hope that I can share some of the experience so you can have a shortcut, don't have to struggle again. Hopefully this tutorial helped. Yeah, if you really like my tutorial, you can just simply subscribe my channel, and you can also leave some comments and let me know what you are interested in, and then I might can include it in my next tutorial. Thank you.